We are doing section 3-4 today, notes on linear programming. Linear programming is a method of finding a maximum or minimum value. We'll do that by using an objective function at the end of our problems. The max or min of a function satisfies the given set of conditions called constraints. Those constraints are going to come from our inequalities. So constraints is one of the inequalities of a linear programming problem. And then the feasible region is where all the final solutions are. It's a solution set for the constraints. It's really where all the shading meets. So if you need a second, pause that. Now, we have already read the first problem, so we're going to jump right in. So what are our variables going to be? We know what they're using, how many pounds of everything. And it says they're making 2 breads. One batch uses 5 pounds of oats, all right, and 3 pounds of flour. Then you've got batch B, it uses 2 pounds of oats and 3 pounds of flour. So I know how much each one uses in terms of pounds. It says the company has 180 pounds, so that's a total of oats and a total of 135 pounds of flour. Write the constraints for the problem and graph the feasible region. Now, a lot of times they come right out and say, how many of this? So constraints mean we're looking for inequalities, and the feasible region is what we're going to get when we graph and shade. But I need to define my variables first. So in order to know how many pounds I need, what would I need to know? Like I would know if I use 5 pounds of oats for each batch A. So to know how many total oats I need, what am I looking for? I'm looking for the amount of each batch. So I'm going to let X be the number of batch A bread, number of batches of bread A, and this is going to be number of batches of bread B. Okay, now you could have worded it differently. You could say amount of bread A, amount of bread B. And you don't have to do this, but for some people it helps. Bread A, it's going to be 5 pounds of oats and 3 pounds of flour. And then the second batch, or bread B, would be 2 pounds of oats and 3 pounds of flour. So that just sort of organizes everything that I have. Altogether, you have 180 pounds of oats. Can you use more than 180 pounds? Nope. So I'm going to fix this here. So I'm going to say my oats have to be less than or equal to 180 pounds of oats. And you also have a limit on flour, so you can't use more than 135 pounds of flour. So what some of us might have been thinking our inequalities were going to be, that might have just changed. Some people were probably thinking to do 5x and 3y, but our totals are oats and flour, so we have to put everything about oats together. How many oats do you use for bread A? 5 pounds of oats, right? So 5 times how many batches would be all the oats from bread A plus bread B uses 2 pounds of oats. So oats and oats has to be less than or equal to 180 pounds of oats. So this equation was all about oats. Pounds of oats times quantity, pounds of oats times quantity, total pounds of oats. Then I have a second equation, and it's about flour. So my constraints were on how many pounds of each thing. So I'm doing 3 pounds of flour times how many I have, and then 3 pounds of flour times how many batch B I have, no more than 135 pounds of flour. Okay, those are 2 of my constraints. Now there are 2 more constraints that are called implied constraints. Implied meaning they should be understood. What kind of minimums should I have? I always need minimums. You say 1. Well, couldn't I use none and just not make something? Okay. I can't have negative numbers. Agreed? I can do maybe I close the bakery and I don't use any pounds of oats and flour. So X has to be greater than or equal to 0 and Y has to be greater than or equal to 0. Now these minimums can change. we could be saying that, like, let's say someone pre-ordered some bread, then I would have a minimum of so many pounds of oats and flour based on what we pre-sold. But if there's nothing that gives me a minimum, I need a minimum. I need my numbers to be positive. Okay, now I'm going to let this sit here, but these two right here are called implied constraints. They're not given to you, but you have to have them. Okay, now we need to graph this, and it says determine the vertices of the feasible region. So that's what's new. Graphing is old. Vertices of the feasible region is new. And what's the feasible region? The final shading, the overlapped region. And vertices are going to be the corners of that shaded region. Okay, so we've got to graph it. You can graph how you want. I was going to do x and y intercepts. So here I go. I'm going to write my first equation as 5x plus 2y is less than or equal to 180. And I'm going to come in and do x and y intercepts. But it's your choice. You can do what you want. At this point, I think we should be able to do it pretty quickly. What do you know about the x-intercept? The y value is 0. You would take 180 and divide it by 5, right? And you would get x is going to be less than or equal to, and I should get 36. Did anyone do the math and see if they agree? Now, I'm keeping my little x is less than or equal to help me shade. Or you could do y equals mx plus b. The y-intercept for this problem, we know that the x value is 0. If you put 0 in here, it would wipe it out. Divide both sides by 2. I get y is less than or equal to 90. So you don't have to use x and y intercepts. I'm going to. Before I start graphing it, I want to figure out what the other intercepts are. So then I have 3x plus 3y is less than or equal to 135. So I'm just breaking everything down. X-intercept, put 0 in. That would wipe this out, and I would divide both sides by 3, and I get 45. And the y-intercept is going to end up being the same, but 0, 45. And both of these, y is going to, or sorry, that was x. Both of them were less than or equal to, so that's going to help me with shading. X is less than or equal to 45. X or y was less than or equal to 45. All right, I have two other ones to graph, and one of them was x is greater than or equal to 0. And what kind of line is that going to be? X is greater than or equal to 0. What's the slope of the line x is greater than or equal to 0? It's going to be a vertical line. This is the one that cuts through the x-axis, so the slope is undefined, and it's going to be my vertical line. And my y is greater than or equal to 0 is going to be a slope of 0, and that is going to be my horizontal line. Okay, so we need to graph. I need to get up to 90. So I counted each block as 5, but each tick mark I went as 10. So you can do what you want. This is going to be 5, 10, but I'm only showing every 10. 15, 20, 25, 30. What else do I need to put with my even interval? What else needs to be on my graph? Labels. I know what x is, number of batch A, right? So amount of batch A bread. I think it could just be bread A, but we'll say that. Okay. And we're going to do the same thing. So 5, and then each tick mark, I'm just counting by 20s. Okay, and this would be amount of, I'm just going to say bread B. Like how many batches of each thing. I guess it's not how many, it's the batches. So we don't actually know how many loaves of bread, we just know how many batches they make. Okay, so I'm going to graph, guys. I'm starting at 0, 90 up here on the y-axis, and then 36 I'm going to have to estimate right there. And then again, you really want a ruler for this. We want to have clear, very accurate lines. Now, both of these were less than or equal to, so I'd be shading in this little corner right here. Okay, I'd really be shading everything, but we know we're going to cut it off. All right, then this guy, we're going both for 45, 0 and 0, 45. And then we are going to draw our line, trying to get it as close to those little intersections as I can get. Notice these are solid lines because it can be equal to. Then I would shade both of these less than. So right now my shaded region is right in here. So you can use highlighters or colored pencils, shade everything and look for the overlap. And then I have my vertical line that's cutting through the x-axis at 0. And then keeping everything in the first quadrant. So even though it's on an axis, you're going to show me that line. See how I extended it? We'd be keeping everything in the positive first quadrant. And then here is your y is greater than or equal to 0. So all 4 lines should show up. Shading in here. So final shaded region is right here along my blue and my pink line. Okay, don't take all day to shade. Now, the problem with using highlighters, if I mess up and pen, I'm out. So we have graphed before, but what's different is it's asking us to pull the vertices. Now, I'm going to pull the vertices, and we're going to have to flip back and forth because there's more to this problem. So what are the vertices, guys? What are the corners? Well, there's one here at 0, 0. Trace around. You turn here, up here, and right here. So we're talking about the corner points of our figure. So we have 4 vertices, and I'm going to list them down here. So 0, 0 is one of the vertices. The other vertice was 36, 0, so it's good that I had that information. Another reason I want to use x and y intercepts is a little more accurate. This one should be 30, 15. I can understand if you were questioning it. And then this one up here was 0, 45. Okay, are you seeing where I got my vertices from? And you see why our graphs need to be so accurate. Having the x and y intercepts is helpful if that's one of my vertices because I'm not guessing what it is. Okay, now we're going to flip it over and do more with this, and I will transfer the vertices so you don't have to keep flipping. Okay, so on the back here, this is now introducing the idea of your objective function. So in most linear programming problems, you want to do more than just identify the feasible region. Remember, the feasible region is that final shaded region, so that little part that I colored in. And anything on the solid line counts. Often you want the combination of values to minimize or maximize a function. This is called the objective function. Okay, the objective of something is your goal, right? So if we're talking about a company making money, would our objective be to minimize or maximize profit? Probably maximize. But if we're trying to run a good business, our goal would be to minimize or maximize costs. Minimize costs, minimize hours, right? Maximize production. So that's the idea. You're going to be told sometimes to find the max and the min, but if it's a word problem with meaning, we might want to minimize the cost or maximize. All of those are called your objective functions. So you have to have more information. What I gave you on the front is not enough information for an objective function, and that's why we have a continued part of the problem here. So Yum's Bakery wants to maximize, so we're looking for a maximum number. It's profit from bread sales. One batch of A yields a profit of $40. Now, there's a difference between profit and revenue. Revenue is just all the money coming in. What's profit? Yeah, the money you make after you pay your employers, after you pay your what's called overhead, which is your rent, your insurance, all the products you buy. Okay, so profit is what you clear. So batch A gives you $40 and batch A or B gives you $30 profit. Use the profit information in the data from example 1 to find out how many batches of bread they should make. Okay, so we have to make an objective function. Now, your objective function can have any variable. We have P for profit. Your objective function will always have a variable, and it's normally a capital letter. So P for profit equals, well, you make a profit of $40 for each loaf. So amount of money times amount of loaves. If you made 10 batches, I should say batches. If you made 10 batches of A, you'd have $400 in profit. And then we would add to it $30 for every batch of B. So your objective function is the same idea of like cost times quantity. So all the money from batches A, all the money from batches made from B, and that's going to be our total money. So we are going to use our vertices. Our vertices were 0, 45. I know I'm listing them in a different order. 36, 0, 0, 0, and 30, 15. And then what we're going to do is we're going to take these x and y values and put it in our objective function. And this is where I'm probably going to use a calculator. P equals 40 times x was 0, and then 30 times y was 45. So what does P equal? So type that in your calculator. We know it's going to be 30 times 45. We should get $1,350. Anybody agree? All right, then we're going to take the 36, 0 and plug it in. It'd be 40 times 36 plus 30 times 0, and my profit would be $1,440. Okay, if we plug 0 and you make no bread, then there's obviously no profit. But we're still going to show that. And then the last one. So probably quicker for you guys to plug these numbers in and do it on your own than try to read what I'm writing, because we're just filling in numbers, typing it in our calculator, and getting that total. You don't have to make a chart, but you should show. So when you do your answers, you should show, here's my ordered pair, here's what I got out. If your inequalities are wrong, then your graph's going to be wrong. But if your graph's wrong, then everything else is wrong. But if you show me, this is what I got, I'll give you credit for all of this, but you'd lose some credit for your graph. So you want to show me this. You might not have to write it all out, but there's that. Okay, so out of all of these, what's the maximum? Okay, so when you go to answer this, we're going to say the maximum profit is what? Probably better if you were focusing on the lesson. The maximum profit is 1,650, and you have your dollar sign. Now, where did that maximum profit come from? The maximum profit was $1,650 from what? 30 batches of bread A, and what? 15 batches of bread B. So your answer to a word problem needs to have everything. Don't just tell me the maximum, but where did it come from and what did it mean? Okay? Okay, so that took a little time. It was a word problem. It's going to happen. So let's look at, so this is considered example 2, but it was a follow-up. Let's go ahead and read the next problem and define our variables. Again, you might want to read these problems twice. So what are we thinking our variables are? This one actually tells you, doesn't it? Find the number of each type of player Sue can send to camp. And what are we trying to do? Maximize the number of players. So we know what we're starting with, and then we know our end goal. The objective is to maximize the number of players. It's not money. Everyone thinks about max and min being money. We just want to maximize how many kids can actually go to this camp. So we have 2 types of players. What did they mention first? Advanced. Okay, so whatever they mentioned first is typically what I use as my first variable. So this would be number of, you can write out the word number, but I'm doing that. Number of advanced players. Now, you don't have to do this, but sometimes it's nice. What information? It costs $150. So each advanced player costs $150. And then this is going to be the number of intermediate player. And that costs $100 for each of them. All right, Sue can spend no more than $16,500. Okay, so here's what I'm looking at. All the money together has to be less than or equal to $16,500. I just like to pull my information. She must send at least 35 more advanced than intermediate players and a minimum of 75 advanced players. So there's two more equations in there. So let's start with this total money. All the money spent on advanced players and intermediate has to be less than or equal to that. So $150 for each of these guys for advanced. So that's total money on advanced plus $100 times each of the intermediate players. Total has to be less than or equal to $16,500. That's one inequality. The other one says she must send at least 35 more advanced players than intermediate. Ideas for that one? Multiply by 35, add, subtract, divide, what? If I say you need 35 more dollars, what would you do with the money you have? Add, subtract, or multiply $35. You would add on another 35, right? Who does she need more of, advanced or intermediate? I heard it. Advanced? Okay. So the advanced players, it says at least 35 more advanced players. So the advanced players have to be greater than or equal to her intermediate players plus 35. A lot of people want to flip that because they're thinking of 35 more advanced players. Your advanced players have to be whatever you have plus 35. Okay, there's another one. It says a minimum of 75 advanced players. Guys, that is just comparing X and 75. So X has to be greater than or equal to or less than or equal to 75. If this is the smallest number she can have, X has to be greater than or equal to 75. Any other implied constraints I need to consider? These are all the ones they gave me. I need minimums. The implied constraints are sort of the idea that I need minimums. I can't send negative players, agreed? Well, the good news is I already have positive because the advanced players has to be greater than or equal to 75. So you should not have X is greater than or equal to 0 because it's already that. So what do I need? What? I'm not hearing you real well. I can't send the 30. Are you saying 35? Oh, you can't put them together. They're two different ideas. So I'm going to put down here y is greater than or equal to 0. So we're going to keep them separate and let the graph work for us. I see what you're saying now. You were looking at these two numbers and saying if you have to send a minimum of 75, then you already know a little bit here. So we don't have to work that out. We're going to let the graph cut it out and work it out for us. But we do need that y to be a minimum of 0. Okay, now these are your constraints, your restrictions, your inequalities. And that's going to cut that graph off for us, and it's going to give you that number you were just mentioning idea. Our objective function is not profit. So we just use P as general. But what's the objective, guys? To maximize the number of what? So everyone gets confused on this, but it's just X plus Y. There's no money here. It's just advanced players plus intermediate. We want the most of them. Okay, before I can find the maximum number of players, I need to graph it and I need to pull my vertices. So this objective function, I'm going to abbreviate, objective function comes into play at the end. You are not graphing it. Okay, so we need to take a little time. I'm going to use X and Y intercepts again. So do a little math, find your X and Y intercepts. I'm going to slide this up. But this is, I'd like you guys to make sure you're comfortable with it. I'm not showing all the math at this point. I'm putting in the 0, So that's going to be gone. I'm dividing by 150. So I'm really expecting you understand the x and y intercept part of this. The y-intercept, I'm putting in the 0 for x. That's going to wipe it out. Divide by 100. We should get 165. All right, so see if you agree with me. Before I try to graph, I want to find all the x and y intercepts so I know what I need to count to. Now, I mean, on this problem, again, you could solve for y equals mx plus b on both problems, but it's up to you. I'm going to stick with x and y intercepts. Oh, and I should put my little inequalities. X be greater than or equal to 35 here. Y-intercept. Oh, all right, I might have to think on this one. 0 greater than or equal to y. So I am moving the y over, and I'm going to divide by a negative, so it's going to flip my inequality sign. All right, well, that's not really going to work for me because I don't have it. I'm not going to have a negative 35 in my graph. Do you see the issue I'm having with this, with the y-intercept here? So we'll talk about that when we graph. I should show here x was going to be less than or equal to 110. And when I solve this, y was going to be less than or equal to 165. What kind of line is the x is greater than or equal to 75 going to be? Like, how do I graph that? Vertical line? Yep. So this one's going to be vertical. And that's why we have to be really careful, because that would change everything on this graph. And then y is greater than or equal to 0 would be my horizontal line with a slope of 0. Okay, so I'm going to come back to this. We'll talk about it in a second. I am going to start by graphing. I need to count to what? 165. So, okay. The problem with counting to 165, I think I can count by 20s, but the problem with counting by 20s is I'm going to have to estimate things. So here's what we're going to do. I can count by 20s, but then I think it's going to be hard to read my graph. So if my y-intercepts are too big, I could always do y equals mx plus b. My concern is if I count by 20s and we're trying to find where they intersect, I might be estimating my ordered pairs. So I am going to come back. Instead of counting and using my ordered pairs, I'm going to do a real quick which pen is this? I'm going to show what this would be. If we took the time, we subtracted 150 divided by 100, we'd get y is less than or equal to 150x plus 165. I'd still have to have a y-intercept of 165, so maybe I just pick some nice points. Like, either way I cut it, that's going to be a hard one to graph. So, let's start with this. Number of advanced players. And we'll come back. Number of advanced players. And this is number of intermediate. All right, so again, you could start your graph at 165 and then come down, but that's going to be really tough. So here's what I'm going to do. Neither of these points are really suiting me as well as I want them to. I'm going to count by fives, each tick mark showing 10. So 5, 10, and then I'm going to show you what sometimes we need to do, because sometimes the x and y intercepts are going to make our graph too small and not accurate because we have to count too far. So I can get my x-intercept in, but my y-intercept is going to make my graph way too big and off the chart. So let me show you what our other options are. Okay, I'm comfortable doing this at 0, 110. Or sorry, 110, 0. Got it? Now, you know how I solve this and we have a slope of, it's not negative 150. I'm sorry, what should my slope be, guys? If you divide by 100, we should have a slope of negative 3/2. So here's what I'm going to do. I'm going to use my 110, 0 as my starting point. I'm going to go up 1, 2, 3 blocks and then left 2. Do you see what I'm going to do? I'm going to use my slope. It's dropping, so I chose to go up 3 blocks and left 2. So this is one way I can do it. I used one of the points I had, and I am just counting out my slope, and I'm going to keep doing it just because I need a super accurate graph. So that's where I'm at. The other thing you could have done is just pick another point, like put a number in for x and find y. You could have put another number in for x and solved for y and gotten another point on the graph. The y-intercept is just too far off this graph, and it would have made my graph too small, and then I wouldn't see where my lines intersect easily. So that's why I chose to do it this way. So again, you could have made a t-chart. You could have done a couple things. Now this one, I can do 35, 0, but 0, negative 35 is down here on the graph. So I'm going to do the same thing here. I'm going to solve this one for y. It is going to be y is less than or equal to x minus 35. Now I know someone's thinking, well, that's not helpful. So guys, I subtracted the y, I subtracted the x, and I divided by negative 1. Okay, how is this helpful? Well, now that I have a starting point, I'm going to go up 1 over 1 because it has a slope of positive 1. And you could see that that would land down here at 0, negative 35. And if I keep following this, what's really nice is I actually find their intersection. So we are looking for accurate intersections. We weren't worried about that with just inequalities, systems of inequalities, but we are worried about it here. So again, can't stress enough, I did have to flip my sign. I had negative y is greater than or equal to negative x plus 35, and I flipped all my signs. Okay, when I talked about graphing this, x was greater than or equal to 35 would be shading this way and this way. This one, they were both less than, so we'd be shading going down. So right now my shaded region is in this triangle sort of spot. Then we're going to do our vertical line at 75, so it cuts through the x-axis at 75. And then if x is greater, it's going to shade right. So now we've cut out this corner, we're right here. And then y is greater than or equal to 0. Even though it's the axis, you're going to show that, and it's going to lock in that shading. So if you're shading everything, that's fine. If you can find it at the end and not be guessing, this is the region that you are shading. Okay, now, I know this is pretty tedious. What are my vertices? And let's move on. So vertices, here's one here at 75, 0. Then I have another one, I'm going to leave some room here, at 110, 0. Then I've got this intersection that worked out really nice at 80, 45. And then you had alluded to this back there. The other intersection is right here, and it's at 75, 40. So do you see how that came together, what you were looking at earlier? Now, beside each of these, I'm going to use my objective function. My objective function was p equals x plus y. So what would p be here? 75. What would be my maximum number of players here? 110. Maximum number of players here, what is it? 125. And maximum numbers of player here, what am I doing? 115? Yeah. So out of all these, which one gives you the maximum number of players? This one. Okay, you can't just leave me that. So what's your final answer? Maximum number of players is 100. Maximum is 125 players. I'll write it that way. And where do we get these 125 players? That is 80 advanced players and 45 intermediate players. Okay. All right, in this last example, everyone's working individually, so we're coming back together to check it. So I've circled everything that's important here. It's important to understand what we're looking for. It says right here, how many of each type of bookcase should the manager purchase? So number of bookcase A, number of bookcase B. I'll know how much footage I have if I know how many bookcases I have. So that's the first thing, is defining your variables correctly and understanding. Now they gave you constraints. The constraints are, like, they gave you lots of information, and I don't know if you guys do this, but I might have done, the store needs 320. So the total is 320 or more. They need 320, so that could be more or that. Bookcase A is 32 feet and it's $200. So here's all my information. And then bookcase B is half of it. It's 16 feet, but it's 125. So if space wasn't, an issue, you could I would order all of these because you're going to get more footage for a little bit better deal. However, there are some restrictions. So space restrictions that most of bookcase A. So here's the first inequality. 32 feet times how many you have. So if you buy 10, that's 320 feet. And then 16 feet times how many you have. Total feet, that's what the 320 is. Then it says no more, or at most 8 of bookcase A. So that's where we're getting X is less than or equal to 8. And then 12 of bookcase B. So the no more than, at most, both of these. And then did you remember your minimum? So for this one, you have 5 inequalities, because it doesn't say you have to have 2 bookcase A. So you need to state that both bookcase quantities have to be greater than or equal to 0. Okay, that's the first part. Now that we have that, all of these are going to be quick lines, right? X is your vertical line, Y's are your horizontal lines. And then this is the one that we need to figure out. So take a minute, find your X and Y intercepts. If the intercept's going to be too far off the graph, you can always use slope or another point. So take a minute, get that information. All right, you might still be working, but, oh, I didn't talk about the objective function. Sorry, last part here. It says how many of each type of bookcase manager purchase to minimize the cost. So that's where the money comes into play. I forgot to talk about that. None of these had to do with money. They all had to do with how many feet. So because it just says they want to minimize the cost, that's how you know to pull the information about the cost. So minimize the cost right here. We pulled that 200 and 125 and we made it our objective function. So that's the ticket. If it tells you to max or minimize something, that's your objective. Okay, so with this in mind, this is the only one that we really had to solve for. Here's the X and Y intercepts. Here's your Y equals MX plus B. Now, I counted by ones. This is a graph where if you count by 5s or 10s, your graph's going to be so little. So I counted by ones and showed every 2. Each block is 1 unit, but I showed every 2 on the tick marks. I have labeled it bookcase A, how many, number of bookcase B. You see that I have my line here starting at 20 or 0, 20 and down here to 10, 0. Make sure you put them on the right axes. And then we're going to make that line. Now, if you're worried about it being accurate, you could always use the slope down to over 1 to make extra points so you're not veering off. Then the other ones, here is your X is less than or equal to 8, going to shade to the left. X is greater than or equal to 0 would be here. Y is less than or equal to 12 is your one horizontal line, and Y is less than or equal to 0 is your other one. So these 2 zeros were actually capped off already by this line being here. Final shaded region, the other ones were down here, but guys, we had a minimum of 320. So this shaded region should be right here. If you can't see it, here it is. Now, even though we have 5 inequalities, we only have 3 vertices. So we're going to pull those 3 vertices, take a minute, pull those 3 vertices, and try them in your objective function because we're trying to find the minimum cost. So one thing I forgot to bring up was the minimum. So the minimum cost is what we're looking for. So anything that had to do with cost gets pulled for objective function. It's not part of our constraints. And some people try to make it one. Our constraint was how many feet we could have and how many bookcases. So minimizing the cost tells me it's my objective. Okay, then we came over here and we dealt with that first equation with x and y intercepts as well as slope intercept form. And so you can graph it 10, 0 and 0, 20. And then if you want it to be really accurate, you can do the slope of down 2 over 1, and that gives us exact points so we don't veer off. Here is our vertical line at x is less than or equal 8, shade to the left. Our horizontal line at y is less than or equal 12, shade down. And then we've got our vertical line at 0, our horizontal line at 0, keeping everything in the first quadrant. So final shaded regions right in here, because remember it was greater than this. And then you are to make sure you count. So I counted by ones, even interval every 2 I showed. Did you label your axes? And then the last thing we need to do is our ordered pair. So we had a point at 8, 4, which was right here. We had a point at 8, 12 and at 4, 12. So I'm showing that I plugged it in my objective function. I showed what I got for each value, especially if I made a mistake, then it would be understood why something was wrong. So final answer is written out. They should buy, this is my max, or sorry, this is my minimum cost, 8 of bookcase A and 4 of bookcase B in order to minimize the cost at $2,100. You could write minimum cost is $2,100 for 8 of bookcase A and 4 of bookcase B. You don't have to write it as a sentence, but you need to have all the information. Are we understanding? All the information is stating, is it a maximum or a minimum? What is it? And what did it come from with labels?